In this module, what we are going to study is in physics, the topic called motion, the movement of an object. In motion, types of motion linear, circular, oscillatory, and random motion or movement, and the definition and unit of displacement and distance, speed and velocity, acceleration, time graph, and equations of motions, that v is equal to u plus at, s is equal to u2 plus half at squared, v squared is equal to u squared plus 2as. So these are all the topics or heading that we are going to in this video. Movement, motion and the types of motion. An object moving from starting point to the end point, depending upon the type, it is classified into linear motion in a straight line, circular motion in a circular path, and oscillatory motion, left and right, that is like that of simple pendulum, and a random motion. There is no proper direction to predict. For example, here the linear motion is given like that, the straight line, the movement of an object is in straight line, and a circular motion is like that of the direction or the type is in circular movement, and oscillatory motion like that is simple pendulum, the clock, old clock direction, the pendulum of the clock, left and right, that is oscillatory motion. And random motion, there is no proper direction or path to follow, zigzag random motion. So called different type of motion or movement. Next heading is uniform and non-uniform motion. Uniform and non-uniform motion. What is uniform? Uniform motion is said to be, it covers equal distance at equal interval of time. For example, if we plot distance against time, the time against the distance, we can point the time with the particular distance, we can get straight line like that for uniform motion, that is for equal distance at equal interval of time. What is called non-uniform motion is unequal distance with equal interval of time is called non-uniform motion. So for uniform motion, the plot of time against a distance is straight line. For non-uniform motion, the plot of time against a distance is curved line like this. Next heading is distance. What is distance? In this diagram, here the movement of an object, from starting to the end, irrespective of the direction. The direction is not given, simply the movement of the object. So called distance. The actual length of the path travelled by a moving body, irrespective of the direction, is called distance. Here there is no direction, so it is a scalar quantity. It is measured in meter in SI system. The unit of distance in SI system is meter, and it is a scalar quantity. Next one is, what is displacement? This one is distance and this one is called displacement. Here upward and downward movement, here the direction is mentioned. Movement of the object in a particular distance along with the direction is mentioned, called displacement. So displacement is defined as change in position of a moving body in a particular direction, as it poses the quantity, the initial and final, and also the direction. So displacement is a vector quantity, as it possesses both the magnitude and direction. So here also the unit of displacement is in SI system meter. So this is the definition of distance and displacement. Distance is actual length of the path travelled by an object, scalar quantity, unit SI system unit is meter, only the magnitude. Displacement is change in the position of an object along with the directions. Along with the direction is called displacement, as it possesses quantity, vector quantity possesses both magnitude and direction. Magnitude and direction is called vector quantity. SI system unit is meter. The next heading is what is speed of an object. Speed of object is calculated by distance travelled by time taken. That is familiar one. The rate of change of distance or the distance travelled in unit time, and it is a scalar quantity. There is no direction given. So speed is calculated by distance travelled by time taken. And also the other formulas are here. This speed calculated by distance by time by the given data, and also from this equation distance is equal to speed into time. Speed is equal to distance by time, distance equal to speed into time. Next one is what is velocity. Next definition, velocity. Velocity is it possesses both magnitude and direction from displacement. So velocity is the rate of change of displacement in a unit time. Here it is given. The displacement in unit time is called velocity, and it is a vector quantity, possesses both magnitude and direction. It is unit of velocity in SI system is meter per second. So velocity is calculated by both magnitude and direction in a given time. That is, both magnitude and direction means displacement. Displacement by time taken will give you the velocity. So next one is what is acceleration. Next one is what is acceleration. Acceleration is the rate of change of velocity in unit time. The change in velocity in unit time is called acceleration. Its unit of acceleration is meter per seconds power minus 2. So change in velocity of an object in a given time is called acceleration. That is, that can be calculated by, the acceleration can be calculated by final velocity minus initial velocity by time. That is change in velocity. Change in velocity calculated by final minus initial in a given time will give you the acceleration. So acceleration, the symbol is A, and the final velocity is V, and initial velocity is U in a given time t. So acceleration formula is equal to A is equal to V minus U by t. This is the graph showing uniform motion when distance and time plotted, it giving a straight line like this. So equal distance at equal interval, the crossed equal distance at equal interval of time called uniform motion. So non-uniform motion, when distance plotted against time, it giving curved line like this, shows non-uniform motion. Equations of motion. The scientist Newton studied the motion of an object, and he gave set of 3 equations called equations of motion. An object with a moving with an initial velocity u and a final velocity v in a given time t, acceleration is a, and reaches the distance s. 3 equations can be written for this motion. That is, again I am repeating, initial velocity is u, final velocity v, acceleration is a, the covered distance is s in a given time t. That is, v is equal to u plus at. Initial velocity, final velocity is equal to initial velocity plus acceleration into time. S is equal to ut plus half at squared. The covered distance s is equal to initial velocity into time plus half acceleration, the time square, the square of the time. And next one is v squared is equal to u squared plus 2as. Here the initial velocity value is equal to the square of the final velocity value square is equal to initial velocity plus 2 into acceleration and the covered distance. So called the equations of motion. How to calculate the initial value, final value and the covered distance with the measured quantities.